We're working through Chapter 5, which is about looping and about files. We're already covered just about the whole thing. And I think we've talked about breaking and continue, but I'm not absolutely sure, so we're going to talk about the last two slides. We will come back to the idea of file I/O again. This was just an introduction to file I/O. When we did our files, what we used was IF stream and OF stream. IF stream allowed us to read in from a file. OF stream allowed us to read out from a file. So IF stream, CN, so it looks something like this. CN.open, and we gave it a file name. Then we checked to see if it existed. If no, not CIN. CIN is already defined, something like FIN. And so if FIN works, then we could read something in from it. FIN into our variable, whatever it was called. Then we would close it. An OF stream uses the other arrows. Otherwise, very, very, very similar syntax. OF stream, fout, fout.open, t.txt. If that file exists, this should not be CIN arrow. What should this really be? What is our file called? What's our file stream variable? Y'all can't see worth a darn because this is off the edge of the screen. Alrighty, now what is the name of our IF stream variable? FN, right. So here, once we've checked to make sure that our file variable was created correctly, we could send something out to it. Now you're probably not going to just read one value in from a file. You're going to read in a loop. So it probably would not be that simple. It would probably be a little more complicated. Not a lot. It would look like this. While FIN arrow var, and then do something with var. Now I don't think my homework asked you to read in anything from a file at all. I could be wrong about that. I think it was just reading output, sending output to a file. Like I said, we will hit those topics again. Breaking and continuing a loop. When you're in a loop, it's going to repeat until the condition is false. But there are ways of modifying its behavior. A break will cause it to exit out of the loop. And if you've taken Python, you probably already have the idea of a break. And it looks like this. For int x is equal to 0, x is less than 10, x plus plus. And then if we did something like this, if x is equal to 5, break, then it would stop at that point. It wouldn't continue with 6, 7, 8, 9. Break just means go to the closing brace, bail out of the loop. So if we did this, if we had that code, what's it going to print? Is it going to print a 0? Yeah, because we started x off at 0. Is it going to print a 1? 2, 3, 4. Is it going to print a 5? Yeah, you have to be careful and not just say no because of the break statement. The print comes before the break. So it will print the x, but then since x is equal to 5, it won't print anything and it'll jump down here. And if we had one more print of some kind just to prove that we were done, then that would print like that. Continue, on the other hand, doesn't cause it to exit the loop. It causes it to reiterate immediately. Jumps back up to the top. Increments the variable, jumps back up to the top. So, for int x is equal to 0, x is less than 10, x plus plus. Let's make it a little more complicated. I should have just copied and pasted. Cout x, arrow, arrow, ENDL. Now let's do if x equals 6, continue. And then let's put some other kind of print. Like that. So what's it going to print then? It's going to print a 0, a 1, a 2, because there's nothing special about any of those numbers at all. Nothing to stop it from doing that. Now when it gets to 6 is where it gets interesting. Is it going to print 6? Yes, it will. But then what happens? Continue. And actually it's not doing that. What is it really doing? I totally flubbed that one. It's going to print 0, and then this is not true, so it's going to skip that, but then what does it print? It prints OK. Same is true for 1. It prints out the 1. This is not true, so it skips that. It prints out OK. 2, OK. 3, OK. 4, OK. 5, OK. 6 is our point where the interesting stuff happens, because it does print out 6. If x is equal to 6, that's a true statement, so it continues. So it immediately increments and reiterates, jumps back up. X becomes 7. Doesn't print out OK. 7, OK. 8, OK. 9, OK. And then it's done. Now I'm not going to make an example that has both of those in it for right now, but we could figure it out if we wanted to. Hope that makes sense. Break causes it to bail out of the loop. Continue causes it to jump back up and reiterate the loop after incrementing again. Kind of like skip to the end. Skips to the end, but it doesn't exit the loop. So anything after the continue statement is not executed after continue is triggered, but it repeats the loop. Anything after the break statement is not executed, but it doesn't jump back to the top of the loop, doesn't reiterate it, it exits the loop. So you can use break to terminate the execution of the loop. Use sparingly, if at all. It makes code harder to understand and debug. Yeah, that's probably a true statement, but if it seems appropriate, go ahead. When it's used in an inner loop, it terminates that loop only. What does that mean? Well, we've talked about nested loops. Something like this. For int x is equal to 0, x is less than 4, x plus plus. And then that's our outer loop. So we have an inner loop for int y is equal to 0, y is less than 4, y plus plus. And then inside our loop, we see out x followed by a space or a comma, followed by a y, followed by endl, and then we do some kind of check. If x is equal to y, break. Let's figure out what that's going to print. I haven't worked this out in my head, but x is 0, y is 0, so it's going to print out x comma y. It's going to print out 0 comma 0, and then what's going to happen? Is x equal to 0 at this point? Is that a true statement? Did I hear it? Yeah, they're equal to each other. So it's going to break. It's going to break out of the inner loop, so now we're here. Let's put some kind of C out, just to make it real clear. Okay, so then it would print out inner loop done. It only broke out of the inner loop, though. It didn't stop the outer loop, so it would jump back up and increase x by 1. Now x is equal to 1, and y starts off at 0, so we're going to print 1 comma 0. Are they equal? Not yet, so it's going to increment y. We get 1 comma 1. Now they are equal, so what's it going to do? Bails out of the inner loop and prints out inner loop done. But we haven't bailed out of the whole loop, so we would come back up here, increment x again, so x is now equal to 2. 2 comma 0. They're not equal. 2 comma 1. They're not equal. 2 comma 2. They are equal, so it's going to stop at that point. It's going to bail out of the inner loop and print inner loop done. Now this is getting tedious, but 3 comma 0, they're not equal. 3 comma 1, 3 comma 2, 3 comma 3, and it would bail out. Now it would have, once we got to 3 comma 3, it would have stopped anyways, right? because when it got to 3 comma 4, is 4 less than 4? No, it is not, so it would have exited the inner loop anyways. Let's play with a nested loop. Go ahead and crank up Visual Studio, make a new project. I'm going to name my project July 9. Add a source file. Got to change the name of the file as well to July 9 CPP. Bless you. I'm going to put my boilerplate in there. I swear I saved it to the desktop, so I ought to be able to find it. Yep. Are we going to use Fstream? No, I don't think so, so I don't think that was a necessary thing. Okay. So you know like how the Bible or whatever is broken up into chapters and verse, and so you say, you know, whatever, chapter 3, verse 12, something like that. We're going to print something out kind of like that. We're just going to have nested loops. So for int chapter is equal to 1, and our book has 5 chapters. So int chapter is equal to 1, chapter is less than 6, or chapter is less than or equal to 5, whichever one you like. Chapter is less than 6. Chapter plus plus. But let's make it so that we have a magic number here. We have this 6 hard-coded here. Let's make it a constant, or let's make it a pound-defined macro. I'm going to come up underneath this using namespace std, and I'm going to do # define num underscore chapters space 6. And that should have been the whole word define, my mistake. # define num underscore chapters 6. And then where the 6 is down here, I'm going to just replace that with that. I'm going to also need a definition for verses. So underneath num chapters, I'm going to define num verses. # define num underscore verses. How many verses are there per chapter? Let's say that there's 4 verses per chapter. So our outer loop is incrementing chapters. Our inner loop is going to increment verse. So for int verse equals 1, semicolon, verse is less than, I need to make these less than or equal to, the way that I've structured these constants. So I'm going to go back and I'm going to make them less than or equal to. Verse is less than or equal to num underscore verses, semicolon, verse plus plus. Now let's have a cout statement. Cout space chapter space end quote arrow arrow chapter. Bless you. Arrow arrow quote space verse space arrow arrow verse arrow arrow endl. And that'll be enough. That'll get our output. How many lines of output are there going to be? It's okay if you don't know, but if you can eyeball it and spot it. We have 6 chapters. We have 4 verses per chapter. How many lines, how many combinations do we have? Is the answer 10? And no, it is not 10. It's 6 times 4. Right, 4 verses per chapter, 6 chapters, 6 times 4. It's going to print out 24 lines of output.
Spell your variables the same way every time.
Yeah, that helps. All right, and there we go. It printed out our verse 1, 2, 3, 4, and 5. Or chapters 1, 2, 3, 4, and 5, verses 1, 2, 3, and 4. One thing I want you to, and I'll drag this out of the way in case you didn't get all the code already. One thing I want you to notice is that the verses increment all the way through before chapter increases by 1. And that makes sense. If you're reading the book, you're going to go through all the verses before you skip to the next chapter. And that repeats. It does another 4 verses, and then it increments chapter. And it does another 4 verses, and then it increments the chapter. And then lastly, another 4 verses. So, the inner loop has to complete before the outer loop iterates again. So there's no kind of intermixing between the inner and the outer loop. As long as it's in the inner loop, it's going to stay there until it's done. And then and only then will it jump back up here. And if we had a break statement inside the inner loop, it wouldn't cause it to break outside of the outer loop. It would only break the inner loop, and then the outer loop would repeat again anyways. Lists are very similar to arrays, but there are some fundamental differences as well. The fundamental difference is that an array, once declared, is always of that size. If you declare an array that's 10 elements long, it's always going to be 10 elements long. But if you had a Python list, you could add elements to the end, right? Or you could subtract elements from the beginning of it, or insert things into the middle, right? So it might start off as 10 long, but then it could grow to be 20 or 100 long, and then maybe you delete a whole bunch of things in it. You can't do that with arrays. If you declare it as 10 long, it's going to stay 10 long. That's the big difference conceptually. The other difference is that an array is contiguous in memory. It's just a block of memory where variables can be defined. Like an apartment complex. And if you're walking down the apartment complex, all the apartments are lined up in order. It's easy to get from one to the next. Now imagine an apartment complex where each door had a little sign telling you to go to the next door. To a different apartment. So you'd go to the first apartment and you'd look at its door and it would say, okay, go to 5 apartments down. And you had to walk 5 down. And then the next one said, go 3 apartments back. And you had to go 3 back. Or lists in Python are implemented as linked lists, meaning that each item internally tells Python where the next one is found. They're not all just contiguous. They're not all straight in a row. So they take a little bit longer to traverse because when the computer's looking through memory, it's got to look up where the next item is and then jump to that item. So it takes 2 reads to access an array, a list. Whereas an array, it just goes straight through it. So arrays are the fastest possible data structure. Are there lists in C++? Yes, they are. They're called vectors. And there may be other data types actually called lists. If you're taking Java, a list is known as an array list. Lists do occur in Java, but Java also has arrays. So everything we learn in C++ about arrays can apply to Java as well, with a few differences. So what is an array? It's a variable that can hold multiple values. Right? You can store 10 names. Previously, up to this point, if we asked somebody's name, we could only put in one name. And then later, if we reuse a variable, it could only hold a different one name. But an array, like a list, can hold a whole bunch of names, or a whole bunch of ints, or a whole bunch of doubles, or whatever. But they all have to be of the same type. Now, I don't know if you used Python like this or not, but a Python list can have any data type in it, followed by any other data type. It can have ints, followed by floats, followed by bools, followed by strings, followed by more ints, whatever. You can mix the types. That's not true of arrays in Java or in C or C++. In a great many languages, they all have to be of the same type. You declare your array. You say this is an array of ints, and then beyond that, all you can store it in are integers. The values are stored in adjacent memory locations. So it's real easy for the compiler to write code that will step through the array. And you declare them using that. In Python, you just did something like this. L is equal to, and then you use some square braces and you put some numbers in there. 8, 6, 7, 5, 3, 0, 9, like that. That's great for Python. That's not the way it works in C. In C, you have to declare the type. You have to give it a variable name. And then you have to say how many items long you want it to be. 1, 2, 3, 4, 5, 6, 7. Like that. Guess that makes sense. It's a phone number. Okay. And then you can initialize it with data if you want. 8, 6, 7, 5, 3, 0, 9. So just eyeball the differences really quickly. In C++ or in C or in Java, you use angle braces to initialize your array. That's a Python list. This is a C++ array. You have to specify the data type. This is going to hold integers. We have to say that it's an int. We give it a name. Yeah, that's the same, but we also have to say how many items it's holding. Now, you can skip that part if you're giving it an initializer list. You could just say that, and then it will go, oh, you want 7 values? I'll give you memory for 7. But if you are not going to pre-fill it with data, you have to specify the length. Like if we're going to declare an array of strings called colors, and then we're going to copy some colors into it. So we could say that colors subscript 0, the first element in let's do red, green, blue, RGB. Color 0 is equal to red. Color subscript 1 is equal to blue, or no, green. Color subscript 2 is equal to blue. Without that, it wouldn't compile. It wouldn't know how much space to give it. Or I guess if it would compile, it's still not going to work when it gets down here. I'm not sure the error message that it would give. We could type it in and find out. Yeah, why not? I'm going to come in here, and above my system pause, I'm going to declare an array of strings called colors, like that. See, it's already giving me grief. And then colors subscript 0 is equal to red. And I'm going to do green and blue. So color subscript 1 is equal to green. Colors subscript 2 is equal to blue. It's not liking that because if we don't specify a length, it doesn't know how long to make the list. Now, if we had put something up here, if we put an initializer list, if we'd use the equal sign and the curly braces, we don't have to specify the length, but without it, we do. So that's saying that we have room for 3 strings. Elements 0, 1, and 2. Subscripts 0, 1, and 2. Index numbers 0, 1, and 2. If we're going to print them out, we will probably print them out with a loop. For int I is equal to 0, I for index. I is less than 3. That's a cheesy way to do it. We ought to find a better way of determining the length of the array. Unfortunately, in this language, arrays can't tell you their length. If you're a Java programmer, you've called array.length, and it's given you the length of the array. If you're a Python programmer, you did len parentheses list name, and it would tell you that it's 3. C++ has no such way of handling it. What you typically do is you define a constant, and you put a constant there, and you can use that constant as the length. But for now, I'm just going to hard code it to 3. Bad programming. So see out arrow arrow. Let's see out the index number followed by a space, so arrow, arrow, space, or double quote, space, end quote, arrow, arrow, the color, so colors, subscript I, and then arrow, arrow, ENDL. All right, and it printed out red, green, and blue. So do notice that it starts counting at 0 rather than 1. It's called zero-based indexing, which means that the last value has to be 1 less than the length, because this is 3 elements. Python lists were the same way, so I'm not going to belabor that too much, but the technical way of saying it is that you can access index values 0 through n minus 1, where n is the length of the array. If we had wanted to define this in shorthand, we could have done that. We could have initialized it as we created it. So string flavors, square brace in square brace, is equal to spicy. Wait, I need the curly braces around it. That's a flavor. Sweet, end quote, comma, sour, end quote, end curly brace, semicolon. Now that list is also 3 elements long. So we could, if we wanted to, put the 3 there. Better not put a number smaller than 3 there. What would happen if we did? What kind of compilation error will it give us? It'll say that too many initializer values, which makes sense. If you have 2 apartments, you can't move 3 families. And there we go. Or leave it out. Either way is just as good. Okay, we're going to declare an array that's 20 integers long, but we're only going to fill up the first 7. So int, and I'm just going to call it Jenny, like Jenny's phone number, 8675309. Int Jenny, I'm going to say I want Jenny to have up to 20 numbers in her phone number. Why, I don't know. Is equal to curly brace 8, 6, 7, 5, 3, 0, 9. And those of y'all who don't know the song, just deal with it. Just roll with it. Okay. You can put any numbers you want in there, but what I really want you to notice is what happens when we print this out. I'm going to print out 20 elements, but we've only got 7 numbers in the array. What are the rest of the numbers going to be? You might think 0. You would be correct. So, for int I is equal to 0, I is less than 20, I plus plus. Let's see out I, followed by a space, followed by that array element. So what is our array name? I will repeat the question. What is our array name? Yeah, Jenny. And to access a specific element in it, we use square braces. And what is our counter variable? Yep, I. Alrighty. And then close square brace, ENDL. So when we run it, we will see the numbers 8675309, but that's not all we're going to see because we're trying to print out 20 elements of the array. And what we'll see is that the rest of them, I have to fix that. I know some other instructor probably needs it exactly like this, but we need it. Okay, that's bizarre. Yeah, you got me. That makes no sense. Okay. So anyways, it printed out, 8675309, but then the rest of them were filled with zeros. So the takeaway of that is that giving it too many initializers is an error. Giving it not enough is fine. What does it do? It fills the rest of them with zeros. What happens if we declare the array but we don't give it any initializing values at all? Put a semicolon after the 20 brace and then semicolon, comment, comment, slash, slash, and run it again. So, after my Jenny 20, I'm going to put a semicolon and then slash, slash, so I've commented out my initializer values. Now this is an uninitialized array. What's going to print out? Is it going to be all zeros? We might like that to be the case. Instead, it says garbage values. Notice it's the same value over and over and over. Microsoft's debug compiler is filling the array, the uninitialized arrays, with a very specific value. Just so that if you ever caught an error, if you ever saw an error, and it printed out something like that, you would immediately know, oh, okay, that's an uninitialized memory address. But if it's compiled for release mode, not debug mode, if it strips out all the debug information, it won't fill it with that specific value. So I'm going to switch my compiler to compile in release mode. If you ever ship code to somebody else, you'll always put release mode, because debug mode has a whole bunch of extra code bound into it to try to catch errors and to help debugging. So I'm going to rebuild it, run it, and there we go. Notice the executable is now in a directory called release, not debug. So I'll have to increase my font size again. All right. So there we go. Definitely not that negative 9 billion or whatever number that was. Just whatever bytes happen to be in that memory before, once, the array just says, okay, give me 20 spaces to fill in, but it doesn't erase them. It's like going to the scrap paper box and grabbing 20 pages and you don't know what's printed on those pages. So it's uninitialized data. So when you create an array, I would always, as a matter of course, go ahead and use an equal sign and just set it equal to a 0. That sets the first value to a 0, and then by default, all the rest of them are also set to 0. Because if you don't do that, then it's uninitialized data and you don't know what's in there. Now maybe you can get away with using that uninitialized data, if you're very careful about what you're saving to it and stuff like that. But I would do that. Better yet, why don't we keep our 8675 data still in there? I'm going to undo that change about commenting out the phone number. All right, let's go about a few more minutes and then we will break. Anybody need any additional typing time? And it's totally okay to say yes. We're all caught up? Okay.
So when you go from the debug to release, is that what turns into an exe?
They're both executables, but yeah, the question is when I switched it over to release, did it make the executable? Debug mode also makes an executable. It just makes an executable that has a whole bunch of debug information included in it. Microsoft bundles it with a bunch of different information. Now, if you're compiling under Mac or Linux or something like that, it's going to be completely debug information if that compiler even supports the idea of debug information, and they do. So if we went and looked, the version of the executable saved out in the debug directory will be larger than the release mode. I'm going to right-click on my solution, go to Open Folder. I'm going to find the debug version of it. The executable is 65 kilobytes long. I'm going to find the release version. It's 14 kilobytes. So it included, an additional 51K, which is a lot of information. That's 51,000 bytes, 51,000 characters of debug information that are in there. And the debug information is what lets the debugger able to step through it, allows the debugger to step through it. The debug information would also assist somebody if they were trying to run what's known as a decompiler. A decompiler takes an executable and tries to turn it back into C or C++ code. And it's much more difficult for a decompiler to do that if the debug information has been removed. And usually you don't want people decompiling your code. So pretty much as a matter of course, if you send your executable out to anybody else, you're going to be changing it to release mode rather than debug. So if we define int tests5, this is saying that we have an array of 5 integers. Index element 0, 1, 2, 3, and 4. And they're all contiguous in memory. Now an int is 4 bytes long. So that would be 4 bytes, that would be 4 bytes, that would be 4 more, that would be 4 more, and that would be 4 more. So 5 is known as the size declarator, the number of elements in the array. And the size of an array is number of elements times the size of each element. Now it's weird that they call it a size declarator and then they give you a different definition of size. If we're talking about ints, then 5 times the size of each element is 4. It's 20 bytes long. So I would call this the byte size. That sounds funny. The byte size of the array is the number of elements times the size of each element. If you're talking about doubles, since every double is 8 bytes long, if you had something that was 10 elements long, 10 doubles, then it would be 10 times 8 for a total of 80 bytes. Now the length of the array is just 10, but the number of bytes that it occupies in memory is 80. So the size of the array is the total number of bytes allocated for it, which you can find out using the size of keyword. So here I have Jenny. I'm going to use size of to find out how much memory that thing is occupying. Cout, quote, size of, parentheses, Jenny, end parentheses, space, end quote, arrow, arrow, and then that's the same thing, size of Jenny. Arrow, arrow, ENDL. Now let's print out the size of each element. Each element is an int. So cout, arrow, arrow. I could just copy and paste to make this easier to type. Size of an int, size of parentheses int in parentheses, arrow, arrow. Size of parentheses int, arrow, arrow, ENDL.
So you said there wasn't a way to get it to tell you how many elements are in the array?
And this is a way of telling you how many elements are in the array, but there's a problem with doing it this way.
Can you divide it by the...
Yes, you divide one by the other and you get the number of elements. Yeah, let's do that. Let's do that. So, but I wasn't lying to you. There's a way, this way works, but it doesn't work in every context. So let's do int len, yeah, len is good enough, is equal to the size of, parentheses, Jenny, divided by size of an int. And let's do cout, arrow, arrow, len, in space, arrow, arrow, len, arrow, arrow, ENDL. Okay, so we declared the Jenny array to be 20 elements long, so its length is 20. Very true. The size of the Jenny array, how many bytes it's occupying, is 80, and the size of each int is 4. 80 divided by 4 is equal to the length. Now the problem with relying upon this as a way to calculate the length of the array, it works perfectly well if the array and the size of commands are in the same block of code. If they're both in scope at the same time, if they're in the same block, if they're in the same pair of parentheses, braces. But if you're passing the array to another function, then the size of array doesn't work. It returns something completely wrong. So you can only use size of as the way to calculate the length of the array if they're both in the same context, if they're both in the same scope. We could try to prove that to ourselves, but if you can accept it for now, then just know that. Size of, this works great, but if you're going to write a function that processes an array, you better pass in the length as well. So let's write a function that prints out the array, and then we'll break. So I'm going to come down here to the bottom. I'm also going to have to declare a prototype. But I'm going to write a function called print array. It doesn't have to return anything, so void print array. This is going to be an array of strings, so print array string. I'm just going to call it AS for array of strings. Square brace in square brace. That says we're taking an array of strings. We don't really know how long it is. So we need a for loop. For, I really wish that I could sometimes disable the IntelliSense that pops up. Anyways, for parentheses int I equals 0, I is less than, I don't know what size to print it to. And if I did this size of business up here, it's not going to work. Just for fun, let's do that. Let's do cout arrow arrow size of parentheses AS end parentheses space end quote arrow arrow size of AS end parentheses NDL, just to find out what it says. I'm going to comment out this for line for now. No, I'm not. Because let's go ahead and write the rest of the code. But for it to work, I have to know the length of the array. So I'm going to have to pass it in. So int len. And so down here, my for loop for int I is equal to 0. I is less than len, I plus plus. Let's see out that element. The name of the array is AS. Our index counter is I. And let's just see out a space rather than a \n so that all of our data will be on the same line. But after our loop, let's see out a \n or an ENDL. I want to change that string to int because I want to pass Jenny to it, and Jenny is an array of ints. So I'm going to come up here and I'm going to change string to int. All right, since I wrote this function beneath the main method, I have to declare a prototype. I could just cut the whole function and paste it and put it above main, but I'm going to declare a prototype instead, and a prototype is the function header just followed by a semicolon. I could memorize that function header, but even easier is if I just highlight that and copy it. Now highlight that, copy it, scroll up and above the word int main, paste it and put a semicolon at the end. Even smarter would be for us to put it in a header file. So up above int main, it's going to say void print array int as square brackets comma int len int parentheses semicolon. Now after I declare Jenny, I'm going to call the print array function. So I'm going to scroll down here. I don't want to jump around too much. I hope everybody has the prototype, and if you don't, I hope you remember how to do it. Just copy the header, go above main, paste it, and add a semicolon. Didn't have to do that. Yeah, you had to do that in Python. You don't have to do that in Java. You don't have to predefine your methods in Java. All right, so anyways, before my pause, I'm going to call the print array function. So print array, parentheses, the array name is Jenny. How many elements do I want to print out? Let's print out 20 of them, because it happens to be 20 long. All right, so check it out. What we were curious about, well, me anyways, was what size of AS was going to be. Up here it's saying the size of Jenny is 80, that array is occupying 80. Here it's saying the size of that array is 4. And that's like a, what in the heck? The array didn't change size. And the reason why is this is actually a pointer. We haven't talked about pointers much, if at all. But a pointer is just a 4-byte memory address that contains the address of the array, not the array itself. And a pointer is 4 bytes long. So if we did that 4 divided by 4, it would tell us that the array was 1 element long. So you cannot trust size of to work on an array inside a function. All right, why don't we take a break and come back at 8:40? If you don't have the code all typed in, then we can finish typing it in. Just let me know about scrolling it up or down. Right here, there. So each element in the array is just a variable. You could do something like this. Int z is equal to Jenny subscript 0 plus Jenny subscript 1. You don't have to type that in because it doesn't mean any. I mean, it's not important. But what it's saying is that Jenny 0 is an int. Jenny 1 is an int. So it's okay to use this. You know, previously we've been doing z is equal to x plus y. Anywhere you could use a variable int, you can use an array int. The same is true for using CIN. We could CIN into Jenny 0 just as easily as we could CIN into any other int. We could C out Jenny just like we've been doing that all along. So let's declare an array and let the user enter 4 pieces of data. 4 test scores, I don't know what. I guess we'll make them double so that they can type in fractions. Double scores, let's make it 4 long. And let's make a little loop so that they can enter the pieces of data. Now don't do it this way. I'm going to type this and I'm going to delete it, so don't follow my lead. That would work, right? But that's silly. How should we really do it?
For loop.
Yeah, we just need a loop. And let's do this the really good way, which is to declare 4 as a constant. So const int num underscore scores equals 4. And then instead of that 4 there, we're going to use num underscore scores. And if I was going to follow all the book recommendations, I would change num underscores to caps. I'm going to leave that alone. Okay, and then we need a for loop to step through them. Let's tell them what to do. C out, enter 4 scores. Hitting return. Or enter 4 scores and hit return. Or let's just say enter scores \n. Now we need our for loop for int I is equal to 0. I is less than num underscore scores. Semicolon, I plus plus, let's ask them for the score, so C out, enter score, and let's print out the number of the score, so enter score space end quote arrow arrow I, arrow arrow, quote, colon, space, end quote, semicolon. And let's let them type it in. CIN, arrow, arrow, scores, subscript I. And I made the arrows go the wrong way? Nope, nope, got it right. Okay. So arrays and loops go hand in hand. You'll almost never use an array without a loop to go with it. All right, so enter score 1, 90. Score 2, 80. Score 3, 70. This is a bad trend. Score 4, 60. All right, now we didn't do anything with those scores. We didn't sum them up. We didn't find the maximum or the minimum or anything like that. But we did some data entry. Let's call our print array function on those scores. So let's see out, here are the scores, \n, and let's call print array scores, and how many scores do we have? We have 4, but what would be better than hard coding the 4? Using our constant, num underscore scores. And that didn't work. Why didn't that work? Because print array is expecting doubles. Excuse me, it's expecting ints. And scores is defined as doubles. I'm a cheat, and I'm going to scroll back up here and change the definition of scores to ints. So where it says const int number scores, I'm going to do const double. No, wait, no, that's not where I change it. Where it says double scores, I'm going to change that to int scores. So I just changed that line. Now, of course, the problem is every time we modify our program to accept input, every single time we run it, we have to type in input. All right, so score 0 is a 100, score 1's a 90, 80, 70. And then it prints out here the scores. We need to get rid of that size of AS. That's kind of spurious output at this point. But it prints out 190, 80, and 70. I ought to just be able to copy and paste this and change it. But I'm going to be rough and tough and retype it. But we're going to need a variable to hold this name of the maximum number, the sum of the scores. Now, calling a variable sum in Python is bad news because there's already a sum function, but not in this language. So we're going to declare an accumulator, and we're going to have a while loop that adds up all the scores in the element. Excuse me, all the elements in the array. Same business for int I is equal to 0. I is less than num underscore scores, I plus plus. And then sum plus equals, what's our array name? Scores. What's our counter? Subscript I. We can also calculate the average. What is the average? It's the sum divided by what? The number, which in this case is num scores. So double AVG is equal to the sum divided by num underscore scores. Let's print those out. C out, arrow, arrow, sum equals, space, end quote, arrow, arrow, sum, arrow, arrow, ENDL. Do the same for average. C out, arrow, arrow, average equals, end quote. arrow average, arrow NDL. And I goofed up because I called it AVG when I declared it, and then I called it average down here when I tried to divide. I just need to change that to AVG to match. All right, let's enter some test scores. I made 100, I made a 90, I made a 90, and I made 100, so the average ought to be 95. Yes. Okay, we can keep going on about using these for loops. What could you use a for loop for? You could find out what the maximum score was. You could find out what the minimum score was. There ought to be a way to sort these scores, probably in a C library of some kind. There ought to be a sort array function available to us. We ought to be able to search for a value. Like if we have a list of names, but we want to change somebody's name to something else, then we could display the list of values, and then we could let them type in a name, and then we would have to search the array for that specific value so that they could change it. Slow me down if you need typing time or typo correction. All right, going to move on. So the size declarator, you usually use a named constant for that, just so that you can pass it around later, and also so that you understand exactly what it means. What do I mean by that? Remember that constants are just like comments in the code, you know. Instead of having a magic number that says 5 there, we might understand what it means. It might mean number of students, in which case we'd put num_students or num_scores. If we ever needed to make it handle a larger number of scores, we would spot that constant and change it. Accessing array elements, we know how to do that. The subscripts start at 0. 0, 1, 2, 3, 4, up to n-1, where n is the length. So the array elements can be used as regular variables. You can copy data into them. You can print them out. You can CIN into them. You can use each one of them as a value for adding or multiplying or whatever. The arrays must be accessed via the individual elements. And when we say accessed, to retrieve the values from them. You can't just do cout tests and have it magically print out the entire array. Unlike Python. Python was great in that respect. You wanted to print a list, no problem, it would do it. So accessing array contents, you do that with either a constant, you could, or with a variable. This is worded wrong. It should be, you can access an element with a variable or a literal. Not a constant or a literal, because a literal is a constant. So either way works. If we set this to 3, the code would be absolutely identical. Cout test subscript 3, I equals 3, cout test subscript I. Using a loop to step through an array. Here we declare our array to be of length 5 by array size, and then we step through it, initializing every value equal to 99. So count equals 0, count is less than array size, count plus plus. Array subscript count is equal to 99. So, remember when I said that the array is not initialized? The data does not, if you don't use an initializer, they don't get set to anything? It's not quite true. If you declare it as a global array, meaning outside of the main method, the main function, they are all set to 0. I would still initialize them anyways. I wouldn't trust that. But it's true. I'm going to type something you don't need to because we're not going to take advantage of it. But if I went up here above main and declared some array, you know, like that, all 4 of those elements are equal to 0 via the magic of it being declared as a global variable. A global variable is one that's defined outside of all the functions. Yeah, get rid of that. I wouldn't rely upon that knowledge. Maybe if you look at somebody else's code and you see a global array, just you know that they're all set to 0. But in your own code, I'd go ahead and initialize it. Why not? How easy is it? You just do equals, brace, 0, end brace. Ta-da, it's done. It only added 4 extra characters to it. There is no bounds checking in C++, meaning that you can run past the end of the array, no problem. C might not tell you it's an error. Java will stop the code. It'll generate a runtime error saying, array out of bounds or subscript invalid or something like that. C++ doesn't give you that hint. The same is true for Python, I believe. If the index, the subscript gets too large for a list, it'll tell you. It'll crash the program. Not C++. Let's kind of prove that to ourselves. Down here, after we enter our 4 scores, let's print out 5 or 6 or 7 scores. Let's change our for loop here so that our for loop is not based on the number of scores, but let's hard code that to like 10. This is dumb, right? Because we only have 4 pieces of data, but I'm going to change that to 10, and I'm going to run it, and I'm going to type in 4 scores and then let it print out 10. The idea doesn't even make sense. We only have room for 4 scores. 100, 90, 90, 100. What's it going to print? Alrighty. Well, when I told it to print it out, I told it to only print out 4. So that was dumb. Let me change our print array to pass in 10. And then I'm going to undo these changes. But I'm going to print out 10 elements rather than 4. 100, 90, 90, 100. Boom, we got 190, 90, 100, and then we got our weird numbers. Somewhere it ran across a 4. I guess that's the size, that's our constant. If we changed our constant to a 5, we'd probably see a 5 there. Anyways, you can see that it's bad data. You should not read past the end of the array. Even worse is writing past the end of the array. I see something worrisome. What is that? A flashing line there. I think that's declaring where the video is recording. Since when did it not video the entire screen? Well, I'm glad it's over on that side that I don't use and not on this side that I use quite a bit in typing and stuff. All right. So, say we only have 4 room here, but we let them type in up to 10. So here's one more num scores that I'm going to replace with a 10 and run it. It's going to want me to enter 10 pieces of data. I only have room for 4. It's like moving families into non-existent apartments. It's not going to work. But it may not tell us that it's not going to work. It may not crash. Let's find out. 100, 90, 90, 100, okay. 100, 90, 90, 100, 100, 90. And it seemed to have worked. We didn't even get any errors. Nothing blew up. But when I let the program close, the Microsoft debugger lets us know. The stack around the variable scores was corrupted. We wrote past the end of the array. That's very useful information. If you ever got this error while debugging it, you should break into a panic. But if you compile it in release mode, we don't have that handiness. We don't have that joy of having it catch that kind of problem. So now I'm going to run it. I'm going to enter 10 scores. 100, well, whatever, you know. Alrighty. It didn't give us an error. But somewhere it was overriding memory it shouldn't. You just don't know what it's going to do. You don't know whether it's going to crash the program. You don't know whether it's going to work cleanly like this one did. You don't know whether it's going to have inconsistent results. You just can't. You just have to be very careful. So define your constants and then use them exclusively. Don't use magic numbers like that. Because what if I'd used a magic number in declaring it and then I changed that and I missed a couple of places? All right, I'm going to undo all that. I'm going to refix my constants. I'm going to take that 10 and replace it with num scores. I'm going to take that 10 and replace it with num scores, and then there was one more. If we worked at it long enough, I could show you an example of when it would change other variables by typing in too many values. We could put in a negative number there, and it wouldn't be a syntax error. Like if I tried to add up, scores subscript -1. Well, in Python, -1 meant something very specific. Anybody remember what a -1 on a list meant?
When you go to the far back.
Yeah, it goes to the far edge of it. It goes to the back end of it. Python's the only language I know that does that. -1 would mean the element in front of the first element, which makes absolutely no sense. And it's not a syntax error, but who knows what you're going to be printing out. Buffer overruns, array overruns, are a very common programming problem. They can crash your program. One way that they can manifest is in input routines. Some languages, the input and the output are done through what are known as character arrays. The C language is like that. And so if you allocate a character array of 20 spaces for somebody's name, but then they type in a name that's more than 20 characters long, it will corrupt the memory. Some people do that intentionally. And if you manage to corrupt the memory just right, you may overwrite a part of the program and be able to revise how the program is supposed to work, and you've created a worm or a virus or something like that. It takes a great deal of skill in order to be able to do that, but of course some people are capable of doing it. And other people are not capable of doing it, but they go on the dark net and they buy, libraries from somebody else that do it. Okay, let's get back into our code. Our lecture. No bounds checking in C. When you use a value as the array subscript, C++ doesn't make sure it's valid. You can use subscripts that are beyond the bounds of the array, that are less than 0 or that are greater than, the length. So here's our array. It's 3 elements long, but our code wrote 5 elements long. So whatever was supposed to be sitting out here, it could have been other variables or, executable code or whatever, gets overwritten. So be careful not to use invalid subscripts. It can corrupt other memory locations. It can crash the program. It could even lock up the computer. Unlikely anymore. Operating systems are much better at checking that kind of thing than they used to be. That Windows error that says, program has performed an illegal operation, shutting it down. It's Windows just making sure you're not writing to memory that the computer, that program doesn't own. And cause elusive bugs. Oh heavens, yes. So off by 1 errors. That's when you use an array subscript that starts with 1 rather than 0. You want to change element 3, so you change array subscript 3. No, the third element is array subscript 2. Or you try to access the last one and it's array of length 100, so you say array subscript 100. That's one past the end of the array. You got to do array subscript 99 in order to get to the 100th element, that n-1 deal. Array initialization. Arrays can be initialized with an initialization list, just like that. Array int test size is equal to that. You could leave that off here. The problem with leaving that off is then you don't really know how long it is, unless you do that size of magic. The values are stored in the array in the order in which they appear in the list. The initialization list cannot exceed the array size, but the array size can exceed the length of the array list, the initialization list. And if that's the case, the rest of the values are just set to 0. So here we have something called months is equal to 12. Let's zoom in on that. and 30 days, that's whatever, April, June, and whatever. 31 days in January, 28 in February. I've always wondered why they, anyways. 31, 30, 31, 30, 31, 31, 30, 31, 30, 31. If oct means 8, then why is October not the 8th month? If deca or decimal means 10, then why is December not the 10th month? Now, one time it was, and then the Romans went and inserted 2 months, into the beginning of it, and it threw the count off, but nobody changed the names of the months. So July and August, July being named after Julius Caesar, and August being named after Augustus Caesar, something like that. It screwed the count up. Anyways, and then so you could run through and print out the months. Notice they did this little +1 here for printing out which month it was. Month 1 has 31 days. Month 2 has 28 days. Month 3 has 31 days. Why did they add 1 to the count when printing it out? They didn't add 1 to the index when accessing it, but they added 1 when they were displaying it. Why would that be?
Because they didn't want to zero the month.
Exactly. A user doesn't know what month 0 is, right? They don't want to see months 0 through 11. They want to see months 1 through 12. So when we're iterating through it, if it's for the user's end purpose, add 1 to it so that it says, elements 1 through 12, or students 1 through 20, or test scores 1 through 5, rather than test scores 0 through 4. To the programmer, it makes perfect sense. To the user, not so much. If the array is initialized with fewer initial values, the rest of them are set to 0. Said that 4 or 5 times. Implicit array sizing is when you don't put a value there. You don't have a size declarator. You don't specify the length, and so the compiler says, oh, you need room for 4. I'm going to make that 4. You have to do one or the other. A range-based for loop. This is kind of how it worked in Python. You could do stuff like this. Say we had our list of colors. C is equal to red, RGB, green, blue. And you wanted to print them out with a loop. You could do this. For color in C, print color. And that would print out red, green, and blue. Totally cool way of doing it in Python. They modified C++ to be able to do the same thing if it recognized the list. And weirdly, you don't have to know the length for this to work. I don't know what kind of magic it's doing. But if you do this in C, let's actually make it look valid. String C is equal to curly brace initializers, red and green, blue. Then you could do for parentheses string color colon C, capital C, and we could print that out. C out, arrow, arrow, color, arrow, arrow, ENDL. What it's doing is it's copying the values in the array and putting them in this temporary variable color so that they could be accessed. Now it's just a copy though. If you tried to change the data as you iterated through it, it would not be changing the original array. So if we said color is equal to orange somewhere in this loop, it's not going to touch this original array. C is a copy, color is a copy of each element successively. That makes sense, that ringing a bell with your Python knowledge or Java. What did they call it here? Every textbook has a slightly different name for this syntax. Range-based for loop. So the range-based for loop. In 2011, they came up with the idea of stealing this feature from Java. It provides a specialized version of the for loop that, in many circumstances, simplifies array processing. Now, when I say that they stole it from Java, that's not accurate. C# had this in the 90s, and Java borrowed it from C#. The range-based for loop is a loop that iterates once for every element in the array. Notice that in our for loop, we didn't say how many elements there were. So honestly, I don't know how that works. We sure had to have it when we wrote our own. Each time the loop iterates, it copies an element from the array into that variable, known as the range variable. I was calling it a temporary variable, they're calling it a range variable. The range-based for loop automatically knows the number of elements in the array. You don't have to use a counter variable. You don't have to worry about stepping outside the bounds of the array. The syntax is much cleaner. If we wanted to print this without a range-based loop, it wouldn't look as nice. Here's what it would look like. For one thing, I'd have to know the length of it. So int len is equal to size of c divided by the size of a string. What you'll also see is people dividing by the size of the first element in the array. This is not the best idea, but you'll see it an awful lot. The size of c subscript 0, because c subscript 0 is a string. So that's a valid way of doing it. The problem is if it is an array of 0 length, which actually is possible. It doesn't sound reasonable. Why would I declare an array of 0 length? But it's certainly possible. Then you're dividing by 0. No, you're not. You're not dividing by 0, but you're accessing an element that doesn't exist. If it's 0 in length, then you can't do c subscript 0 because this has to be n minus 1. There's just no element to access. And so that would generate an exception or otherwise fail. So let's just go with size of string. Nice, safe, clear. The reason they do it the other way, though, is so that you don't have to care about the type of the string. If we did it the way that I just had it, if you change that to an int, then it would automatically account for it. Whereas here, if I make this an int, I have to go down here and make that an int as well. All right, so we have that, and then we'd have to have, for int I is equal to 0, I is less than len, my voice is giving out, I plus plus, and then we could see out, arrow, arrow, c subscript I subscript endl, like that. Now, is that much more code than that? Not really, but if you kind of cross your eyes and you look for which one's messier, you can tell that this is a lot cleaner. If you can get away with using these, I would strongly recommend it. When can you not get away with this? If you have to have the index number while you're processing it for some reason. Like, when we were printing out our arrays, we were printing out the index number and the value. We couldn't do that here. We don't have an index value. And yeah, you could hack it. You could create a counter and add one to it each time. But if you're doing that, you may as well just use this style in the first place. That's one time. The other time is if you need to change the array as you're going through it. And I already mentioned that. What is this kite? This loop up here is the same. I'm going to rewrite this code a little bit. String color equals c subscript I. And then c out color. Now these two chunks of code are exactly equivalent to each other. What does this mean? What if I change color? Color is equal to orange. Is there any reason to expect that that's going to change the contents of the original C array? No, because color is defined right here. Wouldn't change it. It changed the value of that variable, and the next time it iterated, that variable is gone and been replaced by the next element in the array. So this is just a temporary copy of the element. Any changes to it do not take permanent place inside the array. Let's add these as notes. Range-based for loop. Color is a temporary variable. They called it something else. Did they call it the range variable? That receives a copy of each successive element in the array. Range-based for loops are great for better syntax. That's one reason that they're great. Another is you don't have to know the size of it. don't have to know the length of the array through some kind of dark magic. I should Google that up. So these are advantages. Disadvantages. 1, you don't have an index number. So if you need 1, then that's a disadvantage. And 2, you cannot change the values as you step through it. Because the range variable is just a copy of the array variable. All right, I'm going to put that in parentheses because that's a lot of typing, and if I asked you to reiterate this, if I said 2 advantages, that'd be nice for you to say. If I asked you for 2 disadvantages, this would be nice for you to say, but if you left out the parts in parentheses, that's totally cool. Sorry for pausing for a second. I know I have array assignments slotted, created, ready to give you, but I came up with an idea for another one, and now I don't remember it. Dadgummit. Drats. All right. You could already glean the syntax just from our example, but the syntax of it is the word for, of course, and inside the parentheses, the type, int, string, some type that you created, your own class or structure, the name of the range variable, colon, the name of the array. Now if you're going to go on and take C#, I'll just mention that C#, who was kind of came up with this before Java and C++ did, called it a for each loop. And instead of that colon, they use the word each. I like that, the for each loop. I like that better than range-based for loop. And then here's a statement or a block of statements. So modifying an array with a range-based for loop, you can't. And then I always forget this. But you can. If you define your range variable as a reference variable. Now that makes a whole lot of sense because have we talked about references yet? Nope, I don't think so. So, I'm going to add a caveat in here. Unless you declare the range-based variable as a reference. Okay. To do that, you put an ampersand here. That would do it. And I'm sorry I forgot that. Other languages such as Java do not support that syntax, so I forgot that C++ does. I don't know if I can fairly list that as a disadvantage if it's so easy to fix. No, I'm going to just make that a note. You cannot change the values as you step through it unless you declare the range variable as a reference. Like this. For string color colon C, but you have to use an ampersand there. Then sure, you can wipe out that value if you want to. By the time this is done, every element in your array would say orange. The statement that I had as 2 is correct in other languages such as Java, so you just tuck that away in your head, but you remember that in this language you can. Now what is a reference? Nice of them to bring it up without having introduced it. What a reference is a way to actually be able to change the data, the value of a variable inside of a function. And I'll show you what I mean. Go ahead and write this if you want to. Void change it, parentheses int x, and x equals 1000. Now down here inside main, let's create a variable called x. I hope I don't already have one. I'm going to set it equal to 0, and I'm going to call change it, passing in x as an argument to fill in that parameter. And then I'm going to see out after change it, comma, x equals, space, end quote, arrow, arrow, x, arrow, arrow, ENDL, semicolon. All right. If I scroll back up to the top, well, I should just put a pause statement after that. I'm going to do that. So system, parentheses, pause. All right. After change it, x is equal to 0. Now, is that really what we expected? If you've done programming in other languages, that may be what you expected. But why is it equal to 0? We set it equal to 1000 here. And the answer is that it's doing pass by value, which some people call pass by copy. X here is just a copy of this value. It's not the same variable. The fact that they have the same name is totally, that's a phantom. We could change this variable to Fred. The program would work just as well, and it still would not change the value of x. So the problem is that Fred here is just getting a copy of x. It's like I made a photocopy of that variable, and then I handed it to him. And yeah, he wrote on the photocopy, he wrote 1000 on it, but it didn't change my original. All I did is give him a photocopy. Pass by copy, pass by value. The value of this argument got copied into this parameter. But if you want, you can make this a reference. You put an ampersand there, and what it says is that Fred is not a copy of x. Fred is a reference to x. It is x. They are the same thing. So when we change the value of Fred here, we're changing x because they are one and the same. Fred is a reference to x. So when I run it now, it's going to say after change it, x is equal to 1000. There we go. So that's what references are used for. To allow you to pass in data, not by value, but by reference, so that this is actually the same thing as this. Does Python support pass by reference? No. Does Java support pass by reference? No. Does C++? Yep. So does C#. The designers of Java and Python just made a decision that they weren't going to do it for whatever reason. Now, if you define your parameters as references, the program's actually a little bit faster. Why is that? Because it doesn't have to copy the data. Instead, it's getting the variable itself. So it's just passing in an address, 4 bytes, rather than however much data is stored in there. But the risk is that somebody using your function he may think that x is safe. He's programmed a long time in Java. He's new to C++. He doesn't think that a function could change the value of a parameter like that. But it can. Now C# gets away or fixes that problem by making you use something called the ref keyword. In which case, when you define the variable as a reference, when you call a function, you also have to say that that variable is a reference. That lets you know, by gum, he might change x. This doesn't have that option. The ampersand is used in another context as well, if you've heard of pointers. Ampersand is used to get the address of a variable. What if we're curious about the address of x? What's the address of x? What byte is it located in? Above pause, let's print it out. So cout, arrow, arrow, address of x equals space, end quote, arrow, arrow, ampersand x, arrow, arrow, ENDL. And we need to start talking about pointers, so I'll just mention that there. That's how you get the address of x. The address of it's completely different than the value, right? The address says where it's installed, where it is in memory, and the value is a value. Just like the number of the apartment is different from the name of the people who are in it. The people who are in it are the value of the apartment. The number of the apartment is its address. All right, and so it's displaying the address. Now, is that the absolute true address? Is it really in byte 2BF BOC? I'm not sure of that. Operating systems now provide virtualized memory, meaning that while your program is running, it could actually use more memory than your computer has built into it via page swaps. You probably know that your computer has a swap file, and so the swap file is used so that the operating system can farm out more memory than it actually has. Nowadays, in the days of 8 and 16 gigabyte computers, I'm not sure if that's so important, but they all do.
So they basically are using your hard drive for memory instead of your...
Right, exactly. That's what the swap file is doing, is periodically it's writing out chunks of memory to that swap file, and then whenever it needs it, it brings it back in like that.
That's pretty crafty.
It's slow, yeah. So I remember back in some olden days, if you could tell it to not use a swap file, it would speed up the machine, the speed of the machine, but at the expense that the memory was then fixed and it couldn't allocate more memory than it had. But I don't think you can do that anymore. I think those days are long past. So remember our loop that let us enter data into our scores array? Here's what it would look like if we used a range-based for loop. Our range variable would have to have an ampersand in front of it, meaning that we were actually modifying the elements themselves and not just a copy of it. Simpler syntax, that's pretty cool. Next semester, hopefully I'll remember that from the get-go. The range-based for loop versus a regular for loop. It can be used in any situation where you need to step through the elements, but you do not need to know the index, the element subscripts. If you do need the element subscript, you better use a regular for loop. Processing array contents. They are treated as ordinary variables of the same type. If you're using plus plus, be careful. This means something entirely different than this. What does this mean? It means add 1 to the index variable. This means add 1 to that element. So if that element had the number 8 because it was 8675309, that first digit would now be a 9. So to copy one array to another, you can't just do that. You can't say array name is equal to array name. You have to copy them element by element. So you declare 2 arrays. You declare a new array. Why don't we actually code this? We're going to copy those scores into a new array. So I'm going to go back down to the bottom of my code where we were using those scores. I'm going to add a comment. Copy scores into a new array. First thing we have to do is allocate an array of the same length. So double in scores for new scores. Subscript num scores because that's the size of it. And why not initialize it to 0? Even though we're just going to turn around and replace the values, it just makes me feel better to 0 out my array. Now let's use a for loop. For int I is equal to 0, I is less than num scores. I++. And inside it, we're going to set every value of n scores equal to the value of the scores array at that particular index. So n scores subscript I is equal to scores subscript I. And then when we're done, why did I make that double? Make that int. Int n scores. All of our other arrays are ints. That one needs to be 2. And now we could call print array parentheses n scores, and we would see that it has the same data that we entered. And I'm seeing an error. Maybe it just needs compiling. It's flagging it with a little red squiggly. There was a build error. Can anybody guess what I did wrong? Without me actually looking at the error, because I just figured it out. What did print array require as its arguments? It required both the array itself and what? The number of elements. So, comma, num scores. All right. Pressing the key to continue, enter some test scores, 100, 90, 95, 100. And it printed out the copy, 190, 95, 100. So that is how you copy an array. It's very similar to how we printed out the array. It's very similar to how we added the array up. All of your array processing will be done with a for loop. Often it'll be done with a range-based for loop, but in this case we couldn't use a range-based for loop because we had to have the index. And sure, we could have kept the index value as a separate counter anyways and use a range-based for loop, but by the time you're keeping track of a separate counter, you may as well just use the for loop alone. All right, my voice is just about completely failing. We need to think of some homework based on this. Anybody need more typing time on this last example or getting compilation errors? Need me to scroll up or down? Nope. Okay, let's see what homework I had cooked up and if I want to use that one or a different one. Next semester I'm going to ask that they vary my classes between Monday and Tuesday rather than stack 8 hours of lecture on just one day, because that's hard on the voice. Not that you need to know that. Okay. Have we used random numbers yet? That'll be more fun. Yeah, of course we have, because we had test questions over. Okay. So, homework. Declare an array of 20 ints. Fill each element with a random number between 1 and 100. Calculate the sum of the array, calculate the average of the array, calculate the standard deviation of the array. And that's the oh heck. If you haven't taken a statistics course, you don't know what standard deviation is. Google it up. If you can't figure out the formula for standard deviation, text me and I'll give you the formula. But I'd like for you to take a stab at it. You know, if every number in it is the same, then the standard deviation is going to be 0 because the numbers don't deviate from each other. I think that's enough. Yeah, I'm liking that better than the one I already had cooked up. Are there any questions? Hope that's not Freaking you out? It's kind of freaking me out because who has taken statistics? Who knows what standard deviation means? Yeah. So what have you got to use in order to know standard deviation besides the sum? Yeah, you have to have the square root, and there's one more thing. You have to know the sum of the differences, if I'm correct on that. This isn't. We're going to make that extra credit. I'll still give you help if you're tackling it. Just because I'm making an extra credit doesn't mean you have to do it all on your own.
As long as there's no ANOVA or p-values or something like that.
Yeah, yeah. 2 standard deviations away. Nah, okay, so that shan't be terribly difficult, I hope, especially through this. We've already got code samples. Well, you'd have to go back in time to one of our other assignments to remember how to generate a random number, but I know you can do it. And if you can't, ask. All right, any other questions? If you don't mind, I'm going to let us get out a little bit early. I should have like a quiz ready to throw at y'all at the end of the day. Nah.